Welcome back. This will be the last and final installment on the topic of evaluating fractions. All right, so without further delay, let's get started. If 10 pizzas cost X dollars, 6 sodas cost Y dollars, what's the cost of 2 pizzas and 2 sodas in terms of X and Y? Essentially, what the question is asking is how much would this person pay had he or she purchased 2 pizza and 2 sodas, given how much X amount of pizza and Y amount of sodas cost, all right? So we do know 10 pizzas cost X dollars, right? So how many would 2 pieces cost? It'll be 2 times X over $10, right? You just simply cross multiply to determine the cost of 2 pizzas. Similarly, 6 sodas cost Y dollars, right? So 2 sodas would cost 2 times Y over $6, right? You can simplify this even further, as if you divide 10 by 2, then you get X over $5. Similarly, you can simplify the ratio of 2 over 6 even further, which would lead to Y over $3. So we just have to do one more thing to complete the problem, which is the question is asking, what would be the total cost? So total means you have to add the cost of the pizza and cost of the sodas. So it'll be X over 5 plus Y over $3, right? So the common factor in the denominator would be 15. So that means it'll be 3X plus 5Y dollars. And that's it. Very, very simple. Let's continue. This is a very interesting problem because there's just so much happening in the question, but when it comes down to actually solving the problem, it's very simple. And here's my approach towards solving it. The question states, according to the pie chart, what is the degree measure of the sector representing the number of workers spending 5 to 9 years in a similar role is how much greater in the construction industry over the financial industry? Okay. For a novice person that struggles with this sort of question that involves both graph and text, it just increases the complexity simply because of just too many things happening all at once. Okay. One tip I would recommend to you is, if possible, if you can skip and come back, okay, I would skip this question and go to a next one, because the reason these sort of questions do appear, for one reason, while it may truly test your mathematical skills, it also tests how much you can persevere with the whole test, okay? So these questions are thrown in to increase chaos in your mind, okay? So if possible, you can skip, but if you want to persevere and solve it right then and there, then here's how you do it. There's just a lot of terms, a lot of variables, a lot of numbers. So you have to focus what it is that you want. The key here is the degree measure, okay? What's a degree measure? Well, we have a pie chart, so we know the total angle is 360 degrees, right? So let's do the financial industry first. Okay. Financial industry, the 5 to 9 years in a pie chart corresponds to 18%, right? So if 360 degrees is 100%, because that's the whole value, what would 18% corresponds to? That translates into 360 degree times 18 over 100, which is, I believe, is, if my math is correct, I think it's around 65 degrees. You can round it off. So it's 360 times 0.18. Yeah, it's 64.8, and you can round it off to 65 because the answer choice may not be in decimal places. So that's for the financial industry. Similarly, for the construction industry, the employee role who employee who had a similar role in the 5 to 9 year window is 25%, right? If 360-degree corresponds to 100%, then a 25% would correspond to 360 times 25 over 100. I believe it was 90. So let's do the math. Yes, it was 90 degrees. The question is asking, how much greater is that factor, the degree measure in the construction industry compared to the financial industry? Because construction industry comes first, we substitute the 90-degree first, and then substitute the 65-degree for the financial, which would give us, what is it, 90 minus 65 would be, I think, 25 degrees, okay? Now, you would be wondering, why did I not even touch the employee count, which is million, okay? Because the question is not asking about people count, okay? It's asking about a degree measure, okay? It doesn't even ask you, essentially, if you think of it, each circle, each pie chart as actually a real pizza, then what the question is asking, one person's getting a bigger slice and other person's getting a smaller slice. How big is the one person's larger size compared to the person's smaller size? So do you count how many people were eating the pizza? No, that's essentially what this question is trying to do. But what it also does in the process is it throws a lot of things at your face and makes you think you need to somehow use the 12 million. You need to do something else. You just keep thinking, and that's precisely what people that design these tests want you to do, right? So have a plan. And if you're not sure what the question is stating, give it one more chance. Just read it one more time. Keep in mind, you do not have a lot of time, and you do not have to get every single item on the test right to secure a top percentile. If possible, if you're not sure when you read it the first time, I'm just going to skip it. And I think you can always come back to it. So I would suggest you do that. But you say, well, I have just about enough time to give it a shot. Read it one more time, but this time read it a little more slower than you did the first time around. And that's going to tell you what it is that you want. Keep in mind, every question in the world has a keyword. You just have to nail the keyword and work your way back and tie all the ends. Then you will see, okay, this is what I want. And the key here is the degree measure. Once you figure out the degree measure is what you want, then everything else fades away and you get straight to the point. All right. So I may have ranted a little bit there, but this is what I felt when I solved the problem, and I wanted to share my story with you, and that's precisely what I did. All right, let's keep going. 6 contestants have an equal chance of winning a game. 1 contestant is disqualified. Now the remaining 5 contestants have an equal chance of winning. How much more likely is a contestant to win after disqualification? So this problem is very simple than you might think it will be. So at start, it's 1/6, right? That's the probability of one of the 6 candidates winning the game, right? Think about it. You have a coin, heads or tail, right? What are the odds of getting ahead? It's 1/2 because it's head or tail, right? Both of them have an equal probability. So that's why we say half, right? Similarly, 1 or 2 or 3 or 4 or 5 or 6. Those are 6 candidates, right? What is the chance that one of them will win? How is that any different than the head or tail? So that's why we say it's 1/6, right? After the first disqualification, okay? That means now we only have 5 candidates, 1 or 2 or 3 or 4 or 5. Well, how is that any different than here? The only difference is it doesn't have the 6 candidates. So what's the probability of one of the 5 candidates winning? That's 1 over 5. So that will be 1 over 5 probability, right? So how much likely is the contestant to win after the disqualification? We're not quite done with the problem. This is just the probability of one of the 5 candidates. After the disqualification, it'll be, well, your chances are greatly diminished because you could be the next person axed out of the game, right? So it'll be 1 over 5 minus 1 over 6 is the net probability that you could win the game. So the common factor is 30 in the denominator, so it'll be 6 minus 5. So it's 1 over 30 is your probability, net probability of winning the game. Because now you're competing with 5 people and you have just as much of a chance losing the game as much as anybody else. So you have to find the net probability, and the only way you do it is you subtract the probability after the one qualification and the probability at start. That'll give you the net probability. All right. Okay, let's continue. So as I've always said, when you simplify fractions that are already part of another fraction, as in this problem, you want to take the numerator separately and the denominator separately. Work them separately, one step at a time, and then put them back together, and you're done with the problem. So that's precisely what I'm going to do. So I'm going to just take the numerator first, 81 over 5 over 7 over 25. The common factor is clearly 25. So it's 81 times 5 plus 7. This problem, I think, is part of the calculator use section. So I'm going to use the calculator here. I'm not a math genius, so I'm just not going to be able to do these maths in my mind. So it's 405 plus 7 over 25. That's 412 over 25. Let's do the denominator. 1 over 9 minus 2 over 7. And I think 9 times 7 is 63, isn't it? Right. So 63. So this will be 7 times 9 times 2 is 18. So 18 minus 7 is negative 11 over 63. So that means you put it together. 412 over 25 over negative 11 over 63. Remember what I said when you're solving this sort of problem. You retain the numerator as it is and you flip the terms. I'm just going to bring the negative to the front. 63 over 11. And this problem was originally a multiple choice. I removed the answer choices. So I want you to do it without any help, so you don't even guess. So it'll be negative 25956 over 25 times 11. That's 275. This is how precisely it was written. It wasn't reduced any further. I remember the problem very well because of this, the sheer size of the values. So that's how you solve this problem. Now the trick here is when you have a complex problem, break it down into pieces, okay? And you may be an expert in simplifying fractional values, but even you could get carried away when you try to do things too fast. So haste is waste, and you know that. So try to break it into smaller pieces, and eventually you're going to see that, okay, it's very easy, right? So pace yourself and have a plan. All right. In a sample of 114 students, 18% of them liked baseball. And what would be the chance, or how many students would like if the total of students would be 1,200? It's a very simple problem. So 114 is a sample, right? Out of which 18% like baseball, right? So what does that number correspond to? So 114 times 0.18, right? That's about 20.5 students, okay? You can round it off to 21 because you cannot have a 0.5%, right? If this was part of a calculator section, then you don't need to worry. If it is not part of the calculator section, then you're wasting your time trying to use fractional value, round it off, chances are your answer choices are all going to be in whole numbers. So you need not have to worry, just round it off, okay? And the question actually says how many students are likely. So there is a chance that they are assuming that maybe you would have to make some sort of approximation, or maybe they're just using the word likely literally in a very loose sense, okay? Either way, we know that out of 114 students, 21 students like baseball, right? Or play baseball. So what would be out of 1200? What would be out of a sample size of 1200? It's simple. You just cross multiply. So 1200 times 21 over 114. I remember it was around 200 and something. Some change is the answer. So yeah, 221 students. Okay. So chances are you're not going to go wrong by rounding up the 20.5 to 21, simply because your answer choices all will be whole numbers, and so you would have to make some approximation somewhere. And of course, this is an exam problem. This is not happening in real life. Okay. So let's continue. Simplify the expression. And again, as I always said, if possible, simplify. If not, you'd have to deal with it the way it is. So 2x squared over ab power 4 times a power 5 b squared x minus 1, right? I think when one of the problems I did say that if you have a negative exponent, convert it into a positive exponent. So in this case, when it is multiplied, technically it can be written as 2x squared times, right? This is in the numerator, okay? A power 5 b squared x minus 1 over ab power 4. Did you see what I did? Because it's multiplied, it cannot be in the denominator, okay? Because it doesn't have anything. You can assume an imaginary 1 underneath it if that makes you happy. That will put this in the numerator, okay? So that means we can take this x minus 1. There's two ways to do it. Okay, one is you can first cancel out the a to the 5. We know how we do that, right? So a power 5 over a would be same as a power 5 times a to the negative 1. Since the bases are the same, so it's a to the 5 minus 1 equals a to the 4. So this would give us a to the 4. You can retain the 2 as it is. Similarly, b squared over b power 4 will be, well, you know how to do that, right? It's b to the 2 times b to the negative 4, b to the negative 2. Okay, you can either write it in the numerator. For now, let's do that. Okay, or you can write it in the denominator, which I'll also show you. Similarly, x squared times x minus 1 would be x power 1, right? Because x squared times x power minus 1 would be x power plus 1. Now, this problem could be written this way. Alternatively, it could be written this way. Both are correct. Because when a negative exponent in a numerator, assuming the whole thing is divided by 1, a negative exponent in the numerator, when it goes to the denominator, it becomes positive. Similarly, a positive denominator value, when it comes to the numerator, becomes negative. All right. Both of these are correct. I don't remember which one was in the answer choice when I did delete out the answer, the multiple choices. So take my value for it. Both are correct. All right. We have x over 3 plus 11 over 6 equals 6. Remember, again, one end of the expression is very simple. It's just a numerical value 6. So if you can simplify the left-hand side, then equate it to 6, then chances are you're going to make lesser mistake. So let's do that. So x over 3 plus 11 over 6 is, the common factor is 6 here. So we'll take 6 as the common denominator factor, which would give us 2x plus 11, and that will be equal to 6, right? So if you multiply both sides by 6, then we will end up with 2x plus 11 equals 36. 2x equals 25, x equals 12.5. Just do the same math again. So 8 over 3 plus x over 2 equals 4. Because 3 and 2 don't have anything in common, we multiply the 2, so which results in a net denominator of 6 as a common factor. So 3 times 2 is 6, so 2 times 8 is 16. 2 times 3 is 6, so 3 times x is 3x. That's equal 4. You multiply both sides by 6, which would result in 16 plus 3x equals 24. 3x equals 24 minus 16 is 8. X equals 8 over 3. Isn't that simple? It is simple. All right. Solve for x. Again, you can in this particular case, you can determine which side you think is complex and work it and then solve the next side. But ideally, you would have to simplify both sides to a certain form so you can solve the problem even further. So let's continue solving it. So we have 3x plus 12 over 8. For time being, assuming there's a 1. That'll make some of you feel easier when you solve the problem. So the common factor is 8. So it's 3x plus 12 times 8, right? So that'll be what? 12 times 8 is 96. So this will be 3x plus 96 over 8, right? Similarly, let's go do the other end. So it's 1 over 3 minus 2x over 1. So 3 is a common factor, so it's 1 minus 6x, right? Because 1 times 3 is 3, 3 times 2x is 6x. Now let's equate the two. 3x plus 96 over 8 equals 1 minus 6x over 3. You can cross multiply. So multiply this equation by 3 and multiply this equation by 8, which would give us 9x plus 96 times 3 is 288. That's equal to 8 minus 6 8s or 48x, right? So bring the x's to one side and the numbers to the other side, which would give us 48 plus 9 is, we have 57x equals 8 minus 288, which is negative 280. I don't think the question wanted you to solve it any further. You can just leave it be. Again, just like I mentioned in the previous case, I remember very well how this was structured in the multiple choice was because of the sheer size of the values, right? So that's how you solve for the physical value of x, right? Let's solve this problem. I believe we have, okay, we have few more problems. So let's continue. So we have x squared plus x minus 6 and x plus 3. Because the numerator is a quadratic function, chances are if you solve it, you're going to solve the whole problem. Okay, it's only asking you to simplify it. It's not asking you to solve the value of x. If it's asking you to solve for the value of x, then that's a different type that will be part of the excluded variables, which we would look at it later. So let's solve the quadratic equation. We have x squared plus x minus 6. So we want negative 6x squared. So but when we add or subtract, we should get plus x, right? So if you take plus 6x times, how can we do it? Yeah, we can do it this way, right? This will give us negative 6x squared, but 6x minus x, oh, that won't work. Sorry. I know what to see when I make mistakes a few times. So we want negative 6x squared, right? So what can we do? We can multiply 3x times negative 2x, right? Why negative with the 2x? Because we want a positive x. So this will give us negative 6x squared. 3x minus 2x will give you x as well, right? So that means we substitute 3x minus 2x in place of x. So that will be x squared plus 3x minus 2x minus 6, right? So if you split this in 2 halves and you take x as a common factor, so minus 2 x plus 3. So we have x minus 2 times x plus 3 over x plus 3. x plus 3 cancels out, which leaves us with a simplified expression of x minus 2 as the final answer. Simple.